Hi everyone, welcome back to our channel. I'm Bonnie, and today we're diving into the fascinating world of plasma protein binding, or PPB. In this video, we'll start by defining what PPB is and introduce you to the various plasma proteins involved. We'll then explore how PPB displacement works both in controlled lab settings and in real-world scenarios. Let's get started. Plasma protein binding can be defined as the reversible interaction of drugs with plasma proteins. Drugs can also bind to red blood cells, tissue membranes, and other components of blood and tissue. Protein binding can be described as free drug plus free protein in equilibrium with a drug-protein complex. Importantly, it should be recognized that plasma protein binding is reversible, and the binding and release is very fast. When drugs reach the systemic circulation, they are generally transported in the blood by binding to plasma proteins with an amphipathic structure. Amphipathic means that the structure has hydrophilic and lipophilic regions. The hydrophilic region of the protein ensures that the protein itself remains dissolved in the plasma fluid, whilst the lipophilic group loosely binds to lipophilic drugs. Protein-bound drug is not able to cross membranes as they are too big and cannot exert an effect or be eliminated. However, free drug is able to cross membranes to exert an effect or be eliminated. An equilibrium exists between unbound and bound drug. The ratio of bound to unbound drug varies between 0 and 100%, and this process is reversible. This keeps the balance between free and bound drug in the blood. For instance, as free drug leaves the blood, a proportion of bound drug is freed to maintain the ratio. Similarly, if free drug enters the circulation, a proportion of free drug becomes bound to maintain the ratio. Plasma proteins include albumin and globulins. The total plasma protein in a human is usually 60 to 85 grams per liter, with albumin making up around 50 grams per liter. Low plasma protein levels generally reflect low albumin concentrations. High plasma protein concentration can occur in leukemia, Hodgkin lymphoma, and paraproteinemia. Acidic drugs primarily bind to albumin. Whilst basic drugs also bind to albumin, they mainly bind to alpha-1 acid glycoprotein or globulin lipoproteins. Plasma protein binding is a saturable process. Therefore, it is possible, but rare, for drugs to bind to all available spaces at therapeutic doses. An example of a drug that may have saturable plasma protein binding at therapeutic doses is sodium valproate. The fraction unbound is calculated by dividing the unbound serum drug concentration by the total serum drug concentration. The fraction unbound is determined by 1. The affinity of the drug for the protein. 2. The concentration of the binding protein. 3. The concentration of the drug relative to that of the binding protein. If two drugs have an affinity for the same protein, we can get plasma protein binding displacement interactions. In theory, if we conducted an experiment where we added warfarin to plasma proteins within a test tube, 1% of warfarin would remain unbound. If we then added another drug with affinity for the same plasma protein, such as phenytoin, the proportion of unbound warfarin might increase to 2%. However, if we conducted this experiment in a patient, whilst warfarin will still be displaced and unbound warfarin would initially increase, the elimination of warfarin would also increase to maintain a consistent concentration of unbound warfarin. This is because the rate of elimination of unbound drug is equal to clearance multiplied by the concentration of unbound drug. As a result, we would not expect a plasma protein binding displacement interaction to result in clinically significant consequences. Whilst rarely clinically significant, there are scenarios where plasma protein binding displacement interactions may be concerning. Specifically, if a drug's elimination pathway is compromised, for example by reduced liver or renal function, the concentration of unbound drug may remain elevated and cause toxicity. In addition to drug interactions, changes to plasma protein concentrations in certain diseases can also produce plasma protein binding interactions. For example, a decrease in albumin concentrations in pregnancy may result in decreased plasma protein binding. Thanks for watching. I hope you found this module on plasma protein binding insightful and engaging. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more pharmacokinetics content. Don't forget to hit the notification bell so you never miss an update. If you have any questions or topics you'd like us to cover, leave a comment below. Until then, take care and stay informed.